Nice. So today we're going to track a new problem, Facebook post search. So what is Facebook post search? So on Facebook, any user can submit a post. They can share the post with their friends or just make it universally public. And someone can probably search other people's posts based on keywords, maybe semantics, and you can also filter potentially by date and the person, your friends, like within your friends or friends of friends, something like that. Or you can search under a specific person's posts. This is my understanding. So let's check if my understanding of the feature is correct. Okay. Facebook is a social network centered around posts, message. User consume posts via timeline, composed of posts they follow, or more recently that the algorithm predict they will enjoy. Posts can be replied, liked, shared, sometimes with commentary. For this problem, we're zooming onto the search experience of Facebook. This question is primed for infrastructure-style interviews, where your interviewer wants to understand how deeply you understand data layout, indexing, and scaling. Ooh, okay. We're going to assume our interviewer has explicitly told us that we are not allowed to use a search engine like Elasticsearch or pre-built full-text index for this problem. Sure? Okay. So then I think my understanding of the functionality is correct. So the functionality that we need to support, obviously, user can submit some posts, right? User share posts, or let's say user can publish posts, right? And user can search posts based on a bunch of criteria, right? So we're going to support, terms, right? So this is going to be full text search. We're going to support semantics. Right, and and we're going to allow, so user can search posts, right? So let's say this, we can publish posts, we can search posts based on terms or semantics, and we can filter posts, let's say by time range, by the publisher, maybe by location and by friendshipness. So we will say, we will just keep our focus on the time range, publisher, and location for this specific interview, and we will mark, support search, search within friendship distance to be out of scope. Although this is important for production, it's very important for a production feature, but I think because of the time of the interview, so this is not going to be our focus today. Cool. So let's check if we cover the main functionality. So user should be able to create and like posts. User should be able to search posts by keyword. User should be able to get search results sorted by recency or like count. Sure, okay. So we talked about filtering. When it comes to search, right? How do you search? You have full text search. How do you filter? And how do you order it, right? So order results by, time, by submission time, and potentially also by like count. So this is also something they want to support. So publish post and the like post, right? Okay. So, additionally, we talked about filtering, but the interviewer seems to want us to have the filtering functionality being considered out of scope for the interview, right? So let's see. So personalization, sophisticated relevance media, image and media, real-time update. Yep. Okay, so we will move the search functionality as out of scope here, and also move the semantic search out of scope for this specific interview. Okay, sure. So we land on these functionality requirements, and now let's think about what are our non-functionality requirements. So basically, for this specific functionality, the I believe the most important thing is basically the latency and freshness, right? So latency of publish and like. So these are hopefully easier. But we will say the latency for these things will be less than 500 milliseconds. So they have like a very intuitive, a real time user experience. And we will say latency of search to be less than 1 second, right? So this can be slightly longer, but you still want to make it like very interactive. So P99 for both of them will be this number. Um, Additionally, we will probably say, this is latency of search, but we're talking about specific this latency of search time to first row to be less than 1 second, right? So because likely the user can paginate through the search result, and so this is going to be the if they want to get like 1,000 results, then as soon as we show the first 10 results, then they can start reading them, right? And so this will provide a better user experience. And then Naturalist talks about we will be able to paginate through search results, right? So maybe we'll suppose something like that. Maybe let's say up to maybe like 1,000 posts, right? So we will have some potentially have some upper limit to protect our system from being abused. What else? So okay, so we talked about latency. We can also talk a bit about freshness. Now, freshness, ideally, we want this to be strong consistency, right? So, I mean, when I say freshness, I'm also talking about the consistency here. But basically, we don't really need a strong consistency. User publish a post or someone increment the like count of a post. It is okay if it takes like a couple of seconds or a minute before they shows up on the search results. So we will say our freshness to be less than 1 minute, which seems generally good enough for user experience perspective. Okay, so lastly, also very important here is to have being able to support like a very large scale. So we will so let's just collect some basic number here, and I will do the okay, right. So we want to talk about scale. We can think about let's say we have 1 billion user, right? I don't know. So maybe Facebook actually has like 10 billion user, but for the interview, maybe let's say we have 1 billion user, and let's say so because we're not restricting our search scope. So basically, in this specific case, we're allowing every user to search everyone else posts, right? So we have 1 billion user, and let's say every user maybe post 1 post per day, right? That might be, I'm not sure. That might be high, like because there are sometimes you will post more, but maybe some days you don't really post. But let's say on average, 1 post per day. Yeah, this is gonna be on the higher end, right? Because a lot of users they might actually just not be active user, but yeah. So we'll say 1 billion active users, and they post 1 post per day on average, and we will say the size of each post. Let's say that may be about on average. Again, on average, that may be like about 100 bytes per post. But it's also good to think about there can be long posts, right? So let's say we can have max post size being 4 kilobytes per post. Again, these are a bit arbitrary numbers, and we can adjust them in production. So this will allow you to have 4,000 characters, which is actually a pretty long post for Facebook, right? So I think this max 4K is probably reasonable. And we will also think about this is the the right scale, right? So what is the search scale? So we can have again we have 1 billion users, right? And maybe on average 1 search per day for these users. I don't know. So but potentially we will assume that the maybe the read volume is much higher than the write volume. So let's say we have on average 10 searches per day, right? And so this will, gives us 10 billion searches per day. And later on, we can use this number to help us to guide our design. Cool. So, okay, so these are the non-functionality requirements that we want to support. Let's check what the interviewer thinks. System must be fast. Median query should be less than 500 milliseconds. That matches what we are thinking about. The system must support a high volume of requests. Okay, so that's the throughput, the scale. New posts must be searchable in a short amount of time, less than 1 minute. That's exactly what we said. All posts must be discoverable, including old or unpopular posts. Sure. The system should be highly available. Yep, makes sense. So these are the things that we have already covered here. Okay, now, yeah, let's, I don't think, maybe the data model isn't that, okay, so let me just very briefly think about the data model. So we have user, we have post, right? And we probably have some likeness of the post. Yeah, and then we'll have the index result. Okay. So in terms of API, I think, so this is going to be user, so for the first functionality, the user will basically say, we'll have publish post, right? So this will have some, input is user information and the post content, and probably you have an item potency key, right, to avoid inserting the same post multiple times. And then your output would just be like a status, right? And we also have like post, right? So this again will have maybe the user info, who likes what post, right? The post ID and and this may be like or unlike, right? And that has a status. These two are probably pretty straightforward. And then the most important thing is we have our search post functionality. So this will have, again, the user info. This is probably like some user authentication information used, for us to authenticate a user. And this will contain a bunch of terms, right? The most important part is the terms. And then it will contain the ordering criteria. Order criteria. Right, so this might be, time range. Right, what is the time range the user cares about? And this might be also say, should I sort by time or time or like, right, something like that. And we will also carry a limit. Right, so because the user obviously cannot consume everything, so there must be like a limit how many posts I wanna read, right? And so this will also probably have some tokens. So this token will be used to resume to be used to paginate, right? So we can have a pagination token. Right, the pagination token can be used to paginate through the query. And our output would just be, I think, a bunch of post information. Right, so here this will probably just be a bunch of post IDs, right? And then we can allow the users to use the post ID to further, let's say this is post ID plus some, maybe some post meta data and also a small chunk, right? So a small piece of the post. Right? Let's say first 100 words, something like that. So if it's like a very long post, we don't need to immediately send the entire post to the user. We can just give them a short description of the post, and then later on they can use it to find the complete content. Okay, so sounds good. So now we should really go into our detailed design. Okay, so for this let's start from the right path, right? So we can have let's call this publisher. Right, so let's call this publish client. Right, so the publish client will be, it goes to our system. Right, so pass through a gateway. Right, a gateway will be this thing for authenticate the user. Will also be used to route our backend. and maybe also for rate limiting if a user write too often. So we have our gateway, and then this route to our um, publish post service. Okay, so what the publish post service is going to do? So naively, this is going to write the post into our post DB, right? So in the post DB, we will have our post. This will definitely contain some ID. Maybe the creator who created this post, the post content, right? So because we talked about, we kept the post size to be 4 kilobytes, so you can actually just store that within the database. If it's much larger, then you have to consider some alternative storage solutions to store larger content. This will have the time, and this will also have the like count, right? Because later we need to compute the like count of the post, and potentially a lot of other information with the post. Okay, so we say we have our client send a request here, and that goes to our post, and our post will just talk to the post database and insert the post there. We also have the idempotency key, so this will be a unique constraint, right? So that we don't insert the same post multiple times. Cool. Okay, so we have something like that. Obviously, to support the search, we need to have we definitely need to have a full text search index. Whether or not we use the Elasticsearch or we build this ourselves, we will talk about this later on. But let's leave the box here for now, because we also have the. Now, what if there's like user wanna like a post, right? So user wanna like a post, then they will come to gateway. Again, goes to a potentially different service, right? So we can have a like post service. So in practice, maybe you can put them together in the same service, but we will, for clarity here, we will just separate them into different boxes to represent their function, their orthogonal functionality, right? So we have like post service goes in, and then it will also goes to the post DB, increment the like count, and to record that. So obviously here later on we will talk about what about a hotkey issue, right? So if there is let's add a to do here, there can be hotkey issue. A popular post, some celebrity published something, and all of the time everyone is liking that post. How do we handle that, right? So we have the publish client, we have the post like client, right? So yeah, so basically let's say we will just call this client because that doesn't really add too much value to separate them out. Okay. And lastly, we have our post search service. Okay, so we have our post search service. So the post search service will basically goes to the full text search index, right? So use the full text search index to basically filter and ordering, search based on the terms, and grabs a bunch of post IDs, right? And then so get a bunch of post IDs, and then we have to think about, okay, so we say we also want to return some post metadata, right, in the first 100 words. So it also needs to, let's say for now it just goes to the post database, right, to fetch those additional information, like maybe the like count, the timestamp, the creator ID, and also just the first 100 words or like 100 characters of the post content. Right? It reads that and then sends that back to the client, right? And so between the post database to the full text search index, we will have to have a pipeline, to basically maintain this index. Okay, so So for now, we would just say, um, we have a data pipeline here, right? So, oops, okay. So we have let's say we have a streaming pipeline, right? That is consuming from our post database, right? Consuming the updates from the post database and push the update into the full text search index storage part, right? And then we have you know this flows working. Okay, so that's obviously like a very very high level overview of the design. So let's zoom into some of the key components. Um, Now, most importantly, of course, is how do we maintain this full text search index? So the full text search index is typically done by this so-called invert index idea, right? So you have a post where it has a bunch of words, right? So A B C D E F, etc. Let's say I like apple, something like that, right? So the first thing you need to do is to tokenize, right? So we need to tokenize the string, right? And there are multiple ways to tokenize it. You can do full string if you want to only support full string matching, right? Then you can just do full string tokenization. So this will become 3 tokens, right? I like apple. So if the user search any of these, if the user search any of these terms, then we will be able to identify what a post, the corresponding post ID. And but oftentimes user might just do substring search, right? So we also want to support substring search. So typically this can be n-gram search, right? And so instead of just for example the apple, we can actually store app, app-r, and app-re, right? And so for n-gram search, you'd have to configure the min n-gram and the max n-gram, right? So for example here, the min n-gram is 3, so that means if user only search AP, they probably won't get the matching, because that's because we require a minimum of 3 characters to be there. Yeah, actually, so this isn't entirely clear. So we also have PPR and PRE, right? So we have a bunch of those things, right? So similar for the foreground, but we omit it here. So basically, the higher the min n-gram, the fewer storage you have to pay for, and potentially also speed up your query. But that basically limits the scope that you can search for. Now, the max n-gram is similar. So the max n-gram is also used for bounding the amount of storage you want to pay for. So if in this case my max n-gram is app-r, then if the user put in apple, the entire word, that won't give you anything to be searched for. But in general, so we will say, so we will definitely always allow full string matching, and we will probably set a min n-gram to be something like 3 or 4, I would say, and then we don't really set the max n-gram, so user can type in longer and longer, and then they get a more accurate search result. So that's one thing. Yeah, so in this specific case, we're only support string tokenization. In the real full text search index system, they will also support something, for example, like the integer, basically the numeric tokenization. So you can support searching index, searching integer. You can support well, actually, we do have to let's see. So so in this case, we're saying that filter by the timestamp is considered out of scope. But if we also want to support searching by the timestamp, then the typical way is to also tokenize the integer, the timestamp, right? And so you can use a single unified inverted index system to do the entire searching, right? So you don't need to basically you don't need to back join with the main database and then filter by the creation timestamp. Okay, so we have so we talk a bit about how to do the tokenization, and then after we have tokenized data, then we will build this inverted index. Right. Then the next component is to have inverted index. So this will be a mapping from the token to the post ID. And so we will keep the post ID a very small number. So, typically like a int64 or something like that, a 64-bit integer, so that we keep the storage cost as small as possible. And also the post ID is going, and also this is important for the search performance. So we can talk about that. So we have the inverted index, right? So token goes to post ID, and then for the actual search query, this relies on the idea of doing zigzag joining. So the key idea is that the user gives us a bunch of token, and we use this token to get a list of post list, right? So we will say user provide a bunch of terms, right? User provide terms, and then we will tokenize the terms to tokens, and then we will find post list for each token. Okay, so so here, sorry, I made a mistake. Is because so a token goes to a list of post ID, right? So a list of post ID that is sorted. Okay, so this every token points to a sorted list of post ID. So this is called post list, right? So post list is a sorted list of post ID. Okay, so now go back to the search part. So we find a post list for each token, and then we have a bunch of sorted post lists, and then we will do a merge join, right? So basically we say the zigzag join, among all post lists, right? So we can do a zigzag join among all the sorted post IDs, and then we get the intersection, or maybe the union, depends on what is the how the search term looks like, and we get a search result, right? So basically, for example, if the term is, like something like I and like, then we will basically, let's say we tokenize, we only do the full text, full string matching, and then we will get I and like, so we get two post lists, and then we do the intersection between the two lists, right? So intersect between the two post lists, and that is the results that we can return back to the user, right? Another example is if I search for I or like, right? Then we get two post lists, but instead of doing the intersection, we will do a union distinct. Right, so we get a union distinct of the two post lists, and that is the result that we can give back to the user. Okay, so this is sort of like the key part of the search functionality. Now, so one thing there are two things we haven't talked about, right? So let's write them down in case I don't forget them. We didn't talk about sort. We also need to talk about scale. Okay, so let's talk about sort first, because this is a core functionality we need to support. So we want to be able to support searching by the timestamp and also by the scale, right? Okay, so the way to do this is, generally speaking, so we have, if we don't do anything, then we would have to, find all the posts that satisfy the given user input terms, and then we do a post sorting to get the top k results. That is obviously very expensive. So the idea to do that is to pre-sort the data. Right, so let's say sort. Right, so the idea is to pre-sort all the data so that they are already ordered in the desired sorting order, and then the top k query can be satisfied very efficiently. Right. So now we can let's think about how do we pre-sort the data. Mm. Mm. So yeah, because both the timestamp. Okay, so um, let's see. So for the timestamp, then I think maybe like one way is to make our post ID already sorted by the timestamp, right? And so we can write this down. So for the okay, so sort by timestamp. Maybe we can make our post ID instead of like in 64, we can make it a a snowflake ID. Right. So make post ID a snowflake ID so that the post ID is naturally sorted by the timestamp, right? And so in this way, when we intersect our different sort lists, the first k results is going to be what we want to return, right? So so this will basically naturally satisfy our sort requirement. So the downside of this is, right, so it does have a downside because a snowflake ID is generally longer. It is longer than in 64. So this means we have to pay more storage cost, and more expensive join, right? So the zigzag join, now let's say this might be 128 bits, and when we do the zigzag join, it just naturally becomes a bit more expensive because you have more, bits that you need to compare. Okay, so but that's I think is a very natural way to solve this problem. But we also have the requirement to sort by the light count, right? So now you can't really have the light count be part of the post ID, and the post ID anyway can only be sorted by one dimension. So I think so maybe the idea here is to bucketize the likes. Okay, so let's say bucketize post by likes, right? So the idea is maybe most of the let's say, so we will have a bunch of buckets, right? Let's say most of the posts don't have any likes, right? So you have 0 likes, and some posts may have like 1 likes, 2 likes, etc. And then maybe up to 10 likes. And then for posts that have higher than 10 likes, it becomes sparser and sparser. So we will have a larger granularity of the buckets. So maybe this will handle 10 to 20 likes, 20 to 30, etc. And then maybe it goes to 100 to 1,000, right? And then you can go exponentially larger, right? So let's say this may be, for example, 64 to 128 and 128 to 256, etc. Right? And then you have like a max bucket that anything that has larger than 1,000 likes, right? So something like that. So you can pre-bucketize all the posts, and then what you're going to do is when you do the search, you will first goes to search for the largest bucket, right? So I goes to the highest bucket that has a bunch of token to post lists there, and then I search the result. If that gives me, more than k results that I need, then I'm good. I don't need to search for the rest of the buckets. If not, then I go to the next bucket, right? So search will go through buckets from higher to lower, right? Until satisfy the the limit, right? Until we satisfy the limit, and then we will stop there. Now, what is the challenge here, right? So the challenge here is obviously you have to be very careful on the um, bucket boundary selection. You have to be very careful about it. And else you have to what else you need to think about? Um, so you have multiple, you have higher fan out because instead of just like going to one bucket, you have to iterate multiple bucket, higher fan out, and also within a bucket, we will have overscanning issue, right? So because let's say I only want to have 10, the top 10 posts, right? And then they all goes to the 1K plus bucket, the largest bucket. And the largest bucket might actually have like 1,000 or maybe even tens of thousands posts there. Because they are not sorted by the count, right? They're sorted by the post ID. So you would have to basically you would have to scan all of those 10,000 or 100,000 posts and then pick the top 10. So you have a huge overscanning, potentially a huge overscanning issue there. So the trade-off is, this is going to be a trade-off between, overscanning and storage, overscanning and over bucketize, right? Over bucketize, right? So if you over bucketize it, then it is also not good, right? Because you lose the batching efficiency of doing the zigzag join within each bucket. But this generally should be able to satisfy our requirement. Okay, so we mark the sort closed, and lastly we also have scale. So far we're imagining everything is just on a single machine, and then we can maintain all this index and search goes to that machine and do the join. Now for Facebook scale, obviously, so we have let's go back to here, right? So we have 1 billion active user. We have 1 post per day. So that gives us, okay, so I'll do the math. Let's say I will do the math here. So we have 1 billion users times 1 post per day. And then let's say every user are active for 10 years, let's say, right? So we have so many days. And this actually gives us 10 billion. This is actually 1 trillion posts, right? So actually 3 trillion or 34 trillion posts in total, right? So we have 3 to 4 trillion posts in total. And then we also need to think about each post. So we say every post is on average 100 bytes, and maybe that is, so 100 bytes is, yeah, I honestly I don't know. So let's say let's say on average each post is 100 words, right? 100 words per post. Okay, and so this will basically gives us 300 to 400 trillion terms. Right, so okay, so but also we need to think, in addition to that, we also need to think about, it's not only just 100 words per post, right, but we're going to allow substring tokenization. So let's say every word fans out to, maybe 5 5 tokens, right? So every word fan out to 5 tokens. Then this is going to be 500. I don't even know what is that word, right? So this is going to be 1.5 thousand to 2,000 trillion tokens, right? So in total we have like 2,000. Let's say this is 2,000 trillion tokens, right? So that is crazy. So every token, right? So we'll say each token has, this is maybe about like 5 characters, right? So 5 bytes of the token itself, and then let's say plus the 16 bytes of the post ID, right? If we use the Snowflake ID, right? So 5 bytes for the token, and plus 16 bytes for the actual ID, right? So this will be something like this is 20, right? So this is 20, 40,000 trillion token, so 40,000 trillion bytes, and that is like 40 petabyte, right? So our estimation is something like 40 petabyte of storage cost for all the tokens. Obviously, this is pre-compressed data, right? So after compression, maybe it's like just half of the data, but we'll just use this as a ballpark estimation. And so this will require like a massive number of search index to support it, right? And so yeah, so this is really crazy. So to support this fan out, so the general idea is like, so we will shard data, right? So so for scale, we will shard data by token, right? So different tokens goes to different token goes to different machines, and our fan out goes to multiple machines, right? So our search will have high fan out, right? It goes to different machines, and then every machine locally, right? So each server does local zigzag, right? So actually, yeah, that's not really a good idea. So we don't really want to shard data by token. So we shard data by the post ID. Okay, so we shard data by post ID, and then we we cluster the data by the token, right? So we first shard all the data by the post ID, and then within each shard, the data is sorted by the token. So the search will fan out, right? The search will fan out to all servers, right? So it will fan out to everyone, and then each server will do local zigzag join, right? To get top K post ID, and then we need to have a global top K to return the final result. Okay, right. So this is how we sort of like scale the system, and obviously, like now the main challenge here is if any server is down, then your query basically stucks, right? So that is really terrible. There are a couple of ways to mitigate that, both in terms of the product perspective and also technology perspective, right? So how do we handle this fan out, right? How do you handle fan out? Now from the technology perspective, obviously what you can do is you can add read replicas, right? So we can add read replica. Ideally, this is geo replicated, right? So if user is in Asia, then they just talk to the Asia database. User in US talk to the US database, and within each region, you can also have like a massive number of read replicas to serve these things. Now, obviously, this is very costly, right? Especially we talk about the total corporate data size is 40 petabyte, so this is potentially quite expensive. We can have read replica. We can also have cache layer. What else? So we definitely want to do some tricks, right? So is there any tricks that we can do? So this is fan out. So we will also say on the storage, I think it's very important to optimize the storage layer. So you want to have very good compression algorithm, right? So you want to fully leverage, because So you won't have something like columnar storage, or you can have the Parquet format. Right, so you can do the columnar storage, you can do the Parquet format, so that these typically gives you because they store the data for the same column together, so that will give you a higher compression rate. Right, so let's put this down here. So data layout, right? So they will give you better compression format. Compression ratio, and you want to have like a reasonable compression algorithm, right? So for example, the same token will have a bunch of post ID associated with it, so you can use run-as encoding to encode the token column, and for example the post ID column, you can also do delta encoding, right? So that you don't store the full you don't store the full 128 bits. You probably just have a more compact representation for that, etc. So you want to make sure you have good compression, good data layout, and what else? So again, remember, for every token, we will typically just want to get the top K results, right? So that means most of the time we won't reach to the postlets that is beyond the top K, right? So we can have separate hot and cold data, right? So specific here is for things that is posts after top K can be offloaded, right? So can be offloaded to cheaper storage, right? So maybe for the hot data, we actually keep them in memory for faster faster searching. For top K results, we put them on SSD. For non-top K results, we put them on HDD to save the overall cost, right? Now let's go back to our fan out. So we can have read replica being designed. Now a very important thing is, can we think about some sort of scoping, right? So scope the query. So maybe let's say I'm only going to query within last year, right? So that can be one thing. So everything that is above the previous year is not searchable, or that requires like a higher latency to search them. Alternatively, you can say, hey, I only want to search something that is within this geolocation, for example, and then you can partition your search index by the geo boundary. So that will also limit the number of posts you need to search for, right? So that is another option. Other things we can do is, we don't necessarily requires 100% accuracy, right? So we can trade off accuracy. So maybe after 99.9% server finishes, and then we think, yeah, okay, the quality is good enough, right? And we can send results back to the user, right? So we don't always have to wait until the last 0.1% server that comes back to us. So yeah, so these are like a couple of options that we can put into practice to handle the fan out or mitigate the fan out issue. Yeah, so at the beginning we say there's also the hotkey issue that we wanna handle. It is probably like not a main part of this design of this interview, but generally we will say what we probably want is to have a intermediate buffer, right? So instead of just directly go to our database, we will first have a intermediate buffer layer, right? So in memory count. Okay. So if a lot of people are trying to increment count on a specific post, we will first have like an in-memory buffer to pre-aggregate a count, right? In-memory pre-aggregate the count, and then we make fewer transactions to the database to have a bulk increment of the like counts. Cool. I think this covers most of the part I want to talk about.